Hi everyone, so in this video I'm going to go over lots of things to do with quadratics, and I'm going to start with graphing quadratics. So the start here is just lots of information about the graph of a quadratic. So the shape it makes is called a parabola. The point at the bottom, I'm just going to circle it here in black, is called the vertex. And you also have this axis of symmetry here, and the axis of symmetry is the x-coordinate of the vertex. A parabola has a minimum or a maximum turning point depending on the shape of the curve, whether it's a happy face or a sad face. And then you can have x-intercepts and y-intercepts. Now there's different forms of quadratics. There's three main ones. This first one here, where y equals a and in brackets x minus p and the next brackets x minus q. So in this form, the p and the q are actually your x-intercepts. To find the axis of symmetry, you do p plus q divided by 2, and that is the vertex. Also note here the axis of symmetry has x equals. When you're writing an axis of symmetry down as an answer, you have to write x equals the answer, otherwise you won't get the marks. Notice as well in the function, there are minuses here and here. So that is a general form. So what that means is if your p or q is positive, the minus will stay. If your p or q is negative, then that will become a positive in the equation. Next quadratic form, there's two options here. Mainly I look at the second one, when you've got the k. In the first one, the k is just 0. Now this is called the vertex form, and the h and k are actually the coordinates of your vertex. So h is the x-coordinate and k is the y-coordinate. Then the final form is a general form, which you see, which is the ax, this one here, ax squared plus bx plus c. Now in this one, a can't be 0 because otherwise it's no longer a quadratic. C is the y-intercept. If a is greater than 0, so if a is positive, the graph is concave up, it's a happy face. If a is negative, then it's a sad face graph, a sad face parabola. If a is between -1 and 1, then the graph is wider than the original just x squared graph. If a is less than -1 or greater than 1, then it is narrower. And we find the axis of symmetry by using the equation x equals -b over 2a. So I've just got some examples to do with the graphing, so where we're sketching. So example 1, sketch a graph using the intercepts and state the equation of the axis of symmetry. So the first one is y equals 2 multiplied by x plus 3 in brackets multiplied by x minus 1 in brackets. Now this is the intercept form, so you've got your plus 3 and minus 1 here, so they relate to our intercepts. So our x-intercepts, remember the change of signs, they're the opposite, are at -3 and 1. Another good thing then to easily find is the y-intercept. So we just put 0 in for x. So we'd have 2, 0 plus 3 multiplied by 0 minus 1. And when you work that out, you'll get -6. So the y-intercept is at -6. Another good thing to know for this is the axis of symmetry. Our two intercepts, 3 plus 1 divided by 2, which will give an answer of -1. So our axis of symmetry is at -1. So now we can draw the graph. Remember, these graphs, as it says sketch in the question, don't have to be perfect, but they just have to represent roughly where everything should be. Try and draw it to as scale as possible. And then -1 will be right around here. So our graph needs to do that, it needs to come to this point, then go up and look a little bit like that. Once again, it doesn't have to be perfect. As long as the main points are labelled, you're pretty good. B, the same thing. So in B, we've got y equals 1/2 x plus 2 all squared. Now as x plus 2 all squared, there is no k value on the end, which that just means it's going to touch the x-axis. A value at the front is 1/2, and it's positive, so it's going to be a happy face again. Now this value here, the plus 2, that tells us where it's touching the x-axis. So the x-intercept will be at -2, because remember it's with the x-intercepts we use the opposite sign. We can find our y-intercept by just putting 0 in for x. So we have 1/2, 0 plus 2 all squared, which equals 2. Our axis of symmetry will actually just be our x-intercept because it's touching at the bottom of the graph, and then we can draw it. So axis of symmetry is at negative. We know it's a happy face. It's crossing y-axis is 2, and so then we can just draw the graph because we know it's kind of going to look like that. And then make sure everything is labelled. The final graph is -2 multiplied by x plus 1 all squared plus 4. So with this one, our a value at the front, the -2, it's negative, therefore it's going to be a sad face parabola. And what this tells us here is that our vertex is at hk, so it's these two values here. Remember the h, the value in the brackets becomes a negative, and the k stay the same. So our vertex is at -1, 4. We know it's going to be a sad face, so that's going to be a maximum. And then we can find our y-intercept. Just put 0 into the equation, which will give us an answer of 2. And then from there, we can do a quick sketch. So our vertex is at -1, 4, so we'll say that's about here. We know our y-intercept's at 2, and then we can draw the graph. Example 2, consider the quadratic y equals 2x squared plus 8x minus 10. First of all, find the axis of symmetry, so that's it. In this form, the axis of symmetry equation is in your formula booklet. It's x equals negative b over 2a. B is the middle value, so that's 8. So it'll be negative and then 8 over 2 times the a value, which is 2. So the axis of symmetry value will be negative 8 divided by 4, which is -2. Remember, axis of symmetry, we have to write x equals -2. If you don't write the x equals, no marks for the question. Part B, find the coordinates of the vertex. Now we already know the x coordinate, it's -2, because remember the axis of symmetry and the vertex, the x values are the same, which means we just need to put that value into our original equation. So 2 times -2 squared plus 8 times 2 minus 10, and you will get -18. So our vertex is at -2, 18. Part C, find the intercept. So that's the x-intercept and y-intercept. So let's do the y-intercept first because that's the easier one. So y-intercept, make all the x's 0. But remember, in this form as well, as we said earlier, it is actually just your c value, the value at the end, so it's at -10. The x-intercept means we need to solve this quadratic because it is when y equals 0. It's 0 equals 2x squared plus 8x minus 10. Easiest way to do this would be to factor out the 2. So you get x squared plus 4x minus 5, and then that one's an easy one to factorise and solve. You end up with x plus 5, x minus 1. If you're not sure how to factorise quadratics, I do have a video on that, so go watch that one. And then when you do this, you'll find then that x is -5 on x equals 1. So now we have our x-intercepts, and now we can sketch our graph for part D. So let's plot our points. We have our x-intercept at 1. We have the other one at -5. And we have our axis of symmetry at -2, 18. And sorry, that should be -2, -18. So -2 is about there, -18, we're going to say it's somewhere down here. So our point will be that one. And our y-intercept is at -10, around there. And then we just join the dots. And there you go. Next example, now we can look at a graph and find the equation of the graph. So in A, look at what you know and what you can use. So in here, we know the two x-intercepts, so we can use the intercept form. So we can use this form here. So what we need to do first, put in our x-intercepts. So remember, swap the positive and negative, so this will be x plus 1 and x minus 3. Now we need to work out A. To work out A, we can use another point on the graph, and we know the y-intercept is at 0, 3. So what this means we can do is we can put in 3 for our y value, x for our 0. And when we solve that, we'll get 3 equals, now we've got a times 1 times negative 3. So it'd be negative 3a. So our a equals negative 1. And then we can make our final equation. So we can don't have to write the 1, we can negative x plus 1, x minus 3. Now part B, we have quadratic here. Now, because this quadratic touches the x-axis, we know it is going to be of the form a x minus h all squared. Do the same as we did before, put in our h value, which will be minus 2. Then we have our y-intercept at 8, so we can then work out what a is. So 8 equals a 0 minus 2 all squared, which equals 4a, so a equals 2. So our equation is y equals 2, x minus 2 all squared. See? When we look at this one, we know one intercept, we know the axis of symmetry, and we know the y-intercept. Now the axis of symmetry here is important because we know the axis of symmetry is halfway between our two intercepts. So if this is at 1, it means this distance here and this distance here must be the same. So our x-intercepts will be at negative 2 and 4 because there's 3 difference between the axis of symmetry and each side. Which then means we can use our form of our intercept form. So it'd be y equals a, x plus 2 and x minus 4. Just like part A, we have then our y-intercept and we can sub that in to work out what a is. So 16 will equal negative 8a, so a equals negative 2. So the equation will be y equals negative 2, x plus 2 multiplied by x minus 4. The last one, part D, we've been given the vertex, which means we can use the form x minus h all squared plus k. And then remember our h and k are our vertex. So it will be x minus 3 all squared minus 2. Once again, just have to work out what a is by subbing in our y-intercept. So our equation will be y equals 2, x minus 3 all squared minus 2. Last example, find the equation of the quadratic whose graph cuts the x-axis at 4 and negative 3, which passes through the point 2 and negative 20. Now it cuts the x-axis at 4 and negative 3, which means they are our intercepts. So it would be a, x minus 4, and x plus 3. Now it cuts the point at, it goes through the point 2 to negative 20, so we can sub that into the equation. So it doesn't have to be the y-intercept that we sub in, that's just happened to be what we've had previously. You can sub in any point you know on the graph to work out the value of a. So this will be a times negative 2 multiplied by 5, so we'll have negative 20 equals a negative 10a, so a equals 2. And then we can write the equation y equals 2, x minus 4 and x plus 3. Now something to be aware of, sometimes you may need to create the equation in one form, but then convert it to a different form, because that's what the question asks. And so for example, to put this into the general form, you just expand the brackets. And that's the first part of graphing quadratics.